Okay, so we'll start with everyone who is here. I hope. Hello. Hi. Okay, so we'll start with everyone who has. I hope all of you have a few papers with you. Let's say 2 or 3 papers. And the paper protractor which we made last time. We made this triangle thing no last time. So if you have this, it will be great. Okay, so then we can start. Okay, does everyone have it? Can you all show it? Can you raise your hand and wave it like this? Super. Very good. KGBV Konda Park. You have it, right? Okay, super. Very good. Okay, so now, last time, okay, before we start, there was this very cool thing in your the WhatsApp group. No, I don't know, all of you were making these shapes. All of you were making these shapes formation, right? I saw this in all your messages. है ना? हाँ. This is KGBV Sona Nirmal District, KGBV Rajoli. Okay, so this was very cool. I liked all the shapes. There were so many symbols. There was this pie and many more things. So when I saw this, I had like a cool idea. I can't do it alone, but you all are so many people. So I'll give this idea. I don't know if this is even possible, but let's try. Okay. I found this formation very cool. So I thought maybe you can do this. So because we did this last time, so what you could do, okay, just an idea. What you could do is you all had made a triangle, right? You had 1 kid, 2 kid, 3 kid. These are all students. Okay, you all were sitting like this. Okay. So somehow, if you can measure this, if you can keep this angle constant and break from here, like these students can all move and then reassemble so that you can, that angle sum property we verified. No, you remember we had a triangle, we marked all the 3 angles and we cut them and we placed them one beside the other and we showed that, oh, all the angles of a triangle add up to 180 degree, and you have written that this is verification. Okay, this was verification, and this thing you can maybe try in the formations which you made yesterday, day before yesterday, 2 days I'm seeing it. Which are the schools who made it can stand? If a school has done this, maybe I can stand. I'm looking at you. If you have done this, maybe stand or raise your hand. Raise your hand is better, huh? If you have done this, maybe you can show. Okay, I can see many schools. KGBV, Madirala, KGPV, Konda Park, KGPV. Okay, so I can see 2 schools who have done it, and maybe many more has done it. Okay, so very good. If you've done it, it was very cool. I was like, wow, this is so nice. So I got an idea that maybe you can try this way. But if yes, great. If no, it's okay. Okay, so I'll start with today's session by recapping what we did last time. Okay, so last time we made this paper protractor, if you remember. We made this paper protractor which could measure many angles, which could measure 75, 15, 30, 45, 60, 90. And when you open it, it could measure 120 and 150. Right? So while making this, paper protractor, if you remember. Okay. Yes, on the occasion of National Mathematics Day, Swati KGBB ma'am is writing. We did that. Okay, that's so cool. Okay, so now, while making the paper protractor, what we did was, the first step which we did was fold the paper into half. This you can just see, okay? Because now I am going to ask you why this happens, or you can maybe make it. So when you fold it this way, you get a line in the middle. And then what you do is you put one corner on this line such that the fold passes through the other corner here. Okay, there you go. Okay, so you have something like this. You have one corner and you have second corner. Maybe I'll use some color. Okay, so I put one corner on this line and the second corner on this fold. Okay, then what we did was we folded this second flap so that, and you see that it completely overlaps with the given part. Okay, this was the given part. When I fold it, it completely overlaps with this part. This part completely overlaps with this part. Okay. Now, just because this happens, we say that all the three angles were 60 degree. Now, the point here is what we just did when we put this one over the other is we verified. We verified that all the three parts are equal. Now, the question is, why does this fold? Why does this fold here, that is one middle line fold and one placing the corner here, gives you this angle as 60? Why does this happen? Okay, so this is a question which I want all of you to think about. I'll repeat the question. What we did during the session was we folded this paper in half like this. Okay, if you understand my sentences, just give me a thumbs up. What did we do? We folded this paper into half. Okay or not okay? Guttu, ये लाइट चालू कर देना. Okay or not okay? Okay, someone is saying maybe we can't see the paper properly. इसको हटा सकते क्या? 1 second, I'll just remove this. Okay. Now is this better? So what we did was we folded the paper into half like this and we got the middle line. Then what we did was we folded this paper such that a corner comes over the central line here. Okay, and the other corner passes through the other vertex. Now the question is, doing this, we get this angle as 60 or this angle as 30. Why do these two folds give you a 60 and a 30 degree angle is the question. I think the question is clear. Yeah. Okay, I want all of you to think for a minute. Why does these random folds give you a 60 degree, gives you an... I'll show you one more cool thing, okay? Now, if I mark this point, wherever this point, this corner touches this yellow line, if I mark this point and join it with these ends here, this is a simpler question. If I join these ends here, this triangle maybe this red triangle is an equilateral triangle. Equilateral triangle meaning all the three sides are equal. Okay, so this two-fold, that is the middle fold and this fold, gives you an equilateral triangle. The question is why? Okay, if someone wants to answer, they can raise their hand or write it in the chat box. Or I at least want, okay, V Kavita, do you want to answer? I don't know if she raised her hand. Okay, maybe not. If anyone else wants to answer, you can raise your hand. Okay, KGBV, Khanapur, CRT. Okay, let's see if they want to answer. Everyone got the question? I make these two random folds. I fold it into half and then put one corner in the middle line. Okay, I get a point so that we get an equilateral triangle. Why is it an equilateral triangle? K. Manjula ma'am is saying it is half of the equilateral triangle. I am asking you a question before that. Why is it even an equilateral triangle? Why does this random fold give you an equilateral triangle? Okay, I can see people trying to do something. You made it great, but why does it give you an equilateral triangle is the question. What was the fold? Half fold and then a point here. Gives you a point. Join it with the two vertices and you get an equilateral triangle. The question is why? All sides are divided, the middle line exactly half. So it is okay. Very good. Kandhi Saujanya ma'am says that all sides are divided, the middle line. Okay, so the middle line is doing something and so it is equilateral triangle. Okay, so I'll take one more blue pen and what I will do is I'll see this line in the middle, right? I'll fold it like this and I will fold such that the vertex passes through the side corner. Okay. Now what happens, basically what I am saying is, if I take any point on this yellow line, it will always be equidistant from the two endpoints here. Okay, you take any point on this yellow line, this line, this line, this point, this point, this point, this point, this point. You take any. Hello? Okay, you take any point on this yellow line, it will always be at the same distance from the two corners. Okay. Ha. And can anyone tell me what this yellow line is called? Can anyone tell me what this yellow line is called? It is a very special line. I think we spoke about it last time. But what this yellow line does is, this yellow line bisects this red side. Okay, it divides this red side starting from here ending till here into two equal parts. This length and this length are exactly same. Also, this yellow line is perpendicular to, that is, it is a 90-degree angle to this red line. Okay, so this yellow line is called the perpendicular bisector of this red line. Okay, now till now we don't have these triangles, so we'll call it a perpendicular bisectors. Now, a very cool fact about these perpendicular bisectors is that you take any point on them. You take any point on them, join it with the ends. They will always give you a triangle in which two sides are same. These two sides are same. I'll write A, A. Okay? These two sides are same. B, B. Same meaning, equal length. Okay? Then even if I draw it here, these two sides will be same. So I'll always get something in which two sides are same. Now the question is, I want an equilateral triangle. Two sides are already same. Okay, so I want to find a point on this yellow line so that these two sides become equal to the third side, which is the base here. That is why what I do is I fold it like this so that I get this red side and this red side, this red side and this red side equal. But this red side is already equal to this red side. So we get a equilateral triangle. Okay. So we were not able to do this last time. So I thought we'll start by refreshing this. So this is a proof of why when you fold it like this, you get a equilateral triangle here. And now once you get an equilateral triangle, you can see that, oh, this is half of equilateral. So like someone said, half of equilateral. So this is a 30 degree. And so automatically this will be a 60 degree. Okay, you get a beautiful equilateral triangle when you do it this way. Very nice. Okay, so let's start with today's thing and overhead. So all of you have a paper? Yes, everyone has a paper? Okay. Today what we are going to do is, yesterday we made a paper protractor, we made a triangle and we made a triangle like this also. Okay. So today we'll try to fold a paper and cut it in such a way that we get different polygons. Okay. Different sided polygons. Okay. So we'll start with a very beautiful polygon, which is a hexagon. Hexagon meaning how many sides does it have? Hexagon has how many sides? Okay, great. A hexagon meaning I have a six-sided polygon. How does it look like? It looks like 1, 2, 3, 4, 5 and 6. Okay, so we want to make this. What do we do? What are we allowed? We are allowed to fold this paper any way we want and we are allowed to make one cut. Okay, fold however you want and just one cut and I should get a hexagon. Okay, this is your, I want all of you to try for a minute before I tell you how to do. Okay, you have to fold the paper and just make one straight cut. Tuck, 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 tuck. Okay, and you should get a hexagon. Suppose I fold the paper this way. Okay, I fold it into half this way and I make one cut like this. I don't get a hexagon. Hai na? I want you to fold a paper in such a way that one cut in one direction gives you a hexagon. Fold the paper. You don't have to cut it like that. You have to fold the paper and cut it in such a way that in one cut you get a hexagon. Okay, was anyone able to do it? Okay. I think some 1 or 2 schools are trying. Please repeat once again. It's just a question that you have to fold a paper and just make one cut and you should get a hexagon. Okay. That's a question. I want you to try. See, even if you cut it wrongly, that's okay. Okay, it's just one paper wasted. I want you all to try doing it before we do it here. Okay, I don't want a square. I want a hexagon. Okay, let's try. So okay, let's do it with me. Okay. What I can do is I fold the paper into half. A special property of a hexagon is, a regular hexagon is that if I find its center somewhere, I have 6 triangles which are equilateral triangles, which means all these angles here are 60 degree. Okay, this is a very cool fact about hexagons. So I'll use this fact to my advantage. What I do is I fold the paper into half. Cutting at this stage is not very useful. So now what I do is I take the paper protractor I made, and in the center of this folded side, I keep and mark a 60-degree angle. This is a 60-degree angle. Okay. So at this point, this angle is 60 degree. Then what did I do? I folded the paper into half, took my protractor, kept it here, and drew a 60-degree angle. Okay, done. Once you're done, give me a thumbs up. Okay. Could you do it? Okay, done. So many people are showing me thumbs up. Okay. Then what I do is I fold this paper such that along this line. Okay. So I fold along this 60-degree line and I get this one. Okay. Then this leftover piece, I fold it exactly over the previous fold. It will come exactly over the previous fold. If your 60 degrees correct, your next fold will completely overlap with your previous fold. Okay, got it? So you get something like this. On the back side, you will see a straight line, right? This thing. Done? Done this much? Thumbs up, not done. Then what I do is I take a scissor and I cut along this line. Okay, I cut along this line. Now I don't want you all to open this. So I made 3 folds, right? I made a half fold. I made a half fold. I made a 60-degree fold. Something like this. And then I made one more 60-degree fold. Okay. And then I cut this. I made 3 cuts. Okay, the last cut, if I open, what will I get? Can you all tell me, if I open this thing here, what will I get? If I open the first fold, what will I get? I really request all of you to pay a little more attention. Matlab, maybe you can see it in the YouTube once again, but okay, what I did was I folded the paper into half. Okay, all of you did that, very nice. Then I placed my angle here, 60-degree. I wanted to draw 60-degree angle from this side. Okay, so I placed one of the arm on one of the side. Drew this. I got a line here. Okay, so I made a fold along this line. Maybe I can show it this way. Okay, this is one more line. Then I fold it again like this. Okay, and then I make one cut like this. On the back side, I had this straight line here, so I make one cut. Okay, done. Who is this? KGBV Mamda CRT Math. Okay, ma'am, did you get this? KGBV Mamda? Okay. So now the question is, if I open this once, what shape do I get this? If I open this one, I'm not opening it yet. What shape will I get? Only once. I'm not opening the whole thing. I'm just going to open this one fold. And if I do that, I get a rhombus. I don't get a hexagon yet, right? I'm opening it only once. I get a rhombus. It's like a diamond shape. है ना? What is so special about this shape is all the 4 sides are equal and it's not a square because the angles are not 90. So you get a rhombus. Now if I open one more side, what will happen? Can someone tell me? So when I opened once, one triangle became 2 triangle. If I open this, how many triangles will I get? Anyone? If I open this one, how many triangles will I get? A trapezium, very good. So if I open this, like many people said, I get a trapezium. Okay. And if I open this, so I get 3 triangles. If I open this one more time, how many triangles will I get and what shape will I get? If I open this last fold which I made. If I open this last way, you'll get 6 triangles and you will get a hexagon. So I just made one cut and I got a hexagon, right? And while doing this fold, so how do I know where do I have to fold? The first fold I made was along this line, right? And this line divides your shape into 2 equal parts. So this line is called your line of symmetry of a hexagon. What is this called? It's called a line of symmetry. Same way, I could have folded it here also. I could have folded this like this. So this is also a line of symmetry because if I keep it like this, the right and the left are exactly the same. Same way, I have one more fold and this is also the line of symmetry of this shape. Okay, so what I get now is a hexagon. Now, I want you to fold back your hexagon. This is one fold and this is one fold. Okay, so my hexagon is folded back. What I have here is, look carefully, I have a side here which is completely like there are no flaps here. Okay, so this is one side which is completely closed, and this is one side which will have as a 3 flaps. Okay, does everyone get this? Did everyone get this? Okay. Now, so this is completely closed, this is 2, and this has, say, 6 flappers. If you can say, these are the 6 sides of the hexagons which turn out. Okay. So now what I want you to do is, I want you to keep the closed side here in your hand like this. And this is a 2-side flapper, this is a many-side flapper. I want you to bring these 2 corners together. That is the 2 corners of the completely closed side. This was the completely closed side. I bring these 2 corners together. So I get something like this. Does everyone get this? I have a completely closed side. I bring these 2 corners of that completely closed side together. Can anyone tell me what this line, this blue line, does to this angle here? This complete angle here, what does this blue line does to the complete angle here? This blue line is doing something to the big angle here, right? Ha, correct. KGBV Devrupulla. Devrupulla is saying that these 2 angles will be, so this was a right angle, equilateral triangle. What this line does is divides this angle into 2 equal parts, whatever it is, correct. K Manjula Maths, ma'am is correct that this is the bisector of this angle. Okay, whatever is the angle here, it divides into 2 parts. Now what I want you to do is, I have this fold here. I want you to cut along this fold. What will happen? So there is this too many flapper wala thing. Keep that aside. There is this closed and 2 slabs wala. Keep that this thing. Okay. The question is, what will happen when I open this? Can someone tell me, if I open this completely, what shape will I get? What did I do? I have my triangle of hexagon. I had one closed side here. I brought the 2 corners of the closed side together. And after I did that, I got a line which was the bisector of this top angle here. And without opening, you should answer, okay? You should not open and see what you get. The question is, without opening, can you tell me what will happen when I open this? Okay. What shape will I get when I open this? Someone is saying trapezium, someone is saying right angle. Okay. It will be a closed shape, right? Okay. Someone is guessing you'll get a kite. Now we'll surprise. Okay. Now let's see what happens. This fold was the bisector of this line, right? So when I open this line, which was 90 degree here, gets doubled, right? 90, 90, 180. So you get a straight line and you get a straight line here. Then is this fold here. This was some 30-degree or something angle here. So when I open this angle will get doubled. Okay, this angle got doubled. Now, when I open this is the fold, right? So this side will get doubled because this is a 90-degree angle, and this angle will also get doubled because this is a angle bisector. So what I get is a triangle. So when I open this completely, you get a triangle. Okay, and I think this is a equilateral triangle. You can maybe check. You get a equilateral triangle when you open this. Did everyone get it? Can you all show me your hexagons and your triangles? Oh, very good. Good. Realme 7i, I can see. Super. Bantu Sapna. Okay. Very good. Very good. That's your question paper, ah? Eh? Okay. One more school. Okay. How did they cut it? Okay. They have a KGBV physics BKDM KGBV. Okay, super. Let's take. Okay, how these people got a kite. Let's ask them how did they get it. Others I can do. Does anyone want to show how to do this again? Okay. PDPL Ramgiri KGBV. Ma'am, do you want to tell everyone how to do this? Shh. Okay, let's see if I can find you here. No. Yes, ma'am, once again. What to do is take the paper, mark a 60-degree angle, fold it into half, sorry. First fold it into half, mark a 60-degree angle, fold along the 60-degree angle. Okay, after you fold it, you get one more 60-degree here. So you fold that again. Sangeeta ma'am, PDPL, Ramgani. Ma'am, do you get this? This thing? We already did this 2 times. Done? Okay, half fold, very good. Then what you do is you mark a 60-degree angle. Okay, you take your protractor, keep it here and mark a 60-degree angle. Did you all get it? Can I go ahead? Can I go ahead? Has everyone marked the 60-degree angle? If your answer is yes, you can show me a thumbs up. Yeah, I can see some schools who have already made. Some who are doing it again. KGBV Atmakur. Sangeeta Maths. They asked. Okay, and okay, then I'll go ahead. Please repeat. So you fold this like this, mark the 60-degree angle. Then what you do is you fold along this line. Wherever this line is, you fold along this. So you can fold it in the reverse way. Okay. Now once you do that, you make one more fold. So this second angle here, which is left here, the leftover portion will also fold. This is also a 60-degree here. You can take your protractor and you can mark it here. Okay. And then I fold again along this line. Okay. So now what I do is I cut along this thing. Okay, so all of you can do this again. So those who have already done this can make one more hexagon. So now when I open it, I get a hexagon. Do you get this? Has everyone got a hexagon? Okay. Now we'll do something very cool. Can all of you show your hexagons? Hexagon. Open the full thing and show me your hexagon. Rajampet, KGBV. Okay. Okay, can you all show me the hexagon? Very good. Oh, this is very good. Adilabad, KGBV. Very nice. I can see all so many hexagons. Everyone has made a hexagon. Very good. Very nice. Oh. Super, super. Very good. Zafargand, KGBV. Very nice. Okay, all of you have your hexagon? इन लोग का क्या हो गया? Why did you cut your hexagon like this? You cut it from some different place, huh? Okay. Very good. Okay. So I'll remove spotlight from everyone one by one. Okay. Now what I want you to do is hold your hexagon back with me. Like this, and then like this. So I get a triangle. Does everyone get a triangle? Holding your hexagon back, so you get a triangle? Ha, very good. Now this triangle has a closed side, right? And a side which has these two open. And there's one side which has many open. Can you see this closed side? And this two open side? Ah, very good. Now, this closed side and this two open side, you bring them one over the other. Which two sides? Let's see it again. You have this closed side and this you have this two open side. Okay, this is many open, you don't want that. So you have this closed side and you have this two open side. You bring them one over the other like this. Okay, got it? What triangle is this? Some triangle. Could everyone do this? Very good. Now I want you to take a pen and draw along with me. Okay. How do I draw it? How did I fold it? I had this closed side, this two open side. I kept them one above the other and I got a triangle. After this triangle, there's this closed straight side of the triangle, right? What I do is I draw something like this. I draw a half circle, but not complete it. Then I draw two straight lines like this. Then I draw an angle like this. Then I draw two lines like this. And then one line like this. Okay. Half circle, two lines, starting from the closed side. Okay. Half circle, two lines, angle, straight lines, and then one more line. Okay, done. Can you all show me your drawings? Very good. Bantu Sapna. Very good. Ligampet Kamareddy. Very good. Radhika Shivampet. Very good. Super. All the schools, very nice. Okay. Now, can I move ahead? Okay? Not okay? Very good. Very good. Okay. RR District KGBV Chevla. Super. Can I go ahead? I'll go ahead. Now what I do is I cut wherever these blue lines are. I cut wherever these blue lines are. Okay, I remove this, I remove this. I have this. Don't cut everything, okay? Only wherever there is line, you have to cut and remove it. And this final semicircle. Okay. I have this. That if everyone has this, you can show what you have. Don't open it now. We all will open together. Don't open it. Don't open it. Okay, just keep this half thing here. If someone can tell me what will happen when you open it, you can tell me. But others just keep it like this. Keep it in front I'll spotlight everyone. I'll spotlight me also. And we'll open it together. Okay. Oh, very good. I have KGBB, Chevla here. RI. KGBB, Siddipet. Bantu, Sapna. Very nice. Don't open it, okay? We all will keep it like this. I'll have 4 more schools now. Some more schools and we all will open it together. Okay? Anyone else? Don't open it. Sadashiv. This was a very cool school. Okay, okay. All of you have it. Maybe 2 more. Let's spotlight. And 1 more. And let's spotlight. Okay. All of you have it? Now we'll open it together. Okay. What do you think will happen? Let's open it once. And this half doll became a full doll. Okay. Very good. You have a full doll. Now I open it again. And I get 2 dolls. I open it again. And I get 3 dolls. And when I open it again, I get 6 dolls who are holding hands. Yes. Can you all show me your dolls? Oh, very nice. Okay. They cut it something differently and they have 4 dolls, I think. Okay, their dolls are joined together. Very nice. Okay. Yeah, you can show me your 6 dolls holding hands together. Oh, this is very pretty. Very good. Very nice. Super. Can all of you show your dolls like this? Oh, nice, nice, nice. So many schools have their dolls. Very good. All of you have 6 dolls? Very good. Super. Very nice. Yay. Amazing. Now, since we folded it to make a hexagon and we cut it out like that, what we get is 6 dolls holding hands. Okay. So what your homework question is, we'll do one now. And your homework question is, can you make 5 dolls? Can you fold the paper and cut it in this way so that you have 5 dolls holding hands? Okay. So I'll give you one hint. I'll give it very quickly. You can try it. So for 6 dolls, the middle angle which we took, which we folded, was the 60 degree, right? That is why we had got a hexagon. Now for 5 dolls, I want a little more than 60 degrees. And what I want is 72 degrees. Now, how do I measure 72 degrees? I have 75 here. Right? I don't have 72. I have 75. And so what I do is I take a little less than your 70. This is 75. I fold a little less than 75. And that is how I get, let's say, 72 degrees. Then if I make this second fold, what I get is this half portion here should overlap this portion. So a little adjustment here and there you'll have to do. So in the first time when we did this part completely hid this part, no, completely overlapped this part. Now what we'll do is this third part, this third flap will only hide half of the down one. Okay. And now when I fold it nicely and do the same thing again, you can try doing this. You can get a $5. So $6 all of you have made. $5 is homework. $6 mein there's one more cool question. Okay. I drew half dolls, no, here. So 60-degree. Like this. And like this. And I cut it like this. And then I fold it like this. Okay, this. So for $6, I drew half dolls. Now, what if I drew something like this? Okay, now what will I get? Let me cut it. And cut this, and how many dolls would I get is the question. Till I cut this, the same thing, instead of drawing half the doll, I am drawing full dolls. The question is, how many dolls will I get when I open this? Okay, so I'll make cuts like these. In the chat box, oh, very good. Many people are answering it correctly. Okay. And the question is, what do I get when I open this? Up like this. Okay, I'll open this. Oh, many of you have answered this correctly. So you got $6 in the previous case. When I open this, I get double that. That is, I get double of 6 is 12. So I get something like this. Okay. Smaller dolls, but 12 dolls. Okay. Great. Super. Some people are doing this, so we'll maybe wait for a minute. And then we can end the session. Aha, very nice. Try doing the $5 thing, and that's homework. So 6, 12, 8 are all a little simple. Okay. So you can try doing $1, $2, $3, $4, $5, $6, $7, $8, $9, $10, $11, and end at this $12 thing. Okay. So that would be your homework. Very nice. Someone is showing me $1 and $2. Who's this? Very good. You did $1 and $2. Now do 3, 4, 5, 6 and till 12. That is correct. That is 6, 1. Very nice. We did it now, no? Do 5, 6 and all. Very good. Yes. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Super. Very good. Okay. So what we learned today, we learned very simple things and we combined them to make all these pretty dolls, right? I'll remove all of you from spotlights, but very beautiful work. Okay. So we just cut half of the doll and using your lines of symmetry. Do you remember the hexagon and we drew the lines of symmetry, half were same, half were same, half were same. So using your lines of symmetry, what you did was you just cut half the doll and you got 6 different dolls because you had folded the paper in that way. Okay? So this is how, instead of cutting 6 dolls separately, you can fold the paper in such a way that it gets replicated multiple times. Okay, so I don't know if all of you are listening. I think many of you are doing it. Okay, so your homework today is, there will be a link sent to you with homework plus an extra homework which I am asking you because you have done the homework, because you have attended the class. I want you to try making 1 doll, 2 doll, 3 doll, 4 doll, 5, 6, 7, 8, 9, 10, 11 and want you to end this with 12. Okay, it's not very easy, but in the starting, I had seen you all make triangles and squares with your whole body. So I think you can do this also very easily. Okay. Okay, if okay, you will give me a thumbs up. Do you understand what the homework is? Understand what the homework is? Okay, big thumbs up, everyone. Very nice. Okay, just like you hold your hands, I want these dolls holding hands and in different numbers. Okay, so once you do this, you have a WhatsApp group where you can post all this. Okay, your teachers can open WhatsApp, take your photos, send it there. Okay, okay, very beautiful. Let's maybe we can end YouTube. YouTube, I think everyone has got it. And